So welcome everyone. This session is called Exploring a Risk Approach to Software Supply Chain Security. My name is Abdullah Garcia. Just very briefly, I'm a senior lead cybersecurity architect, been working in the finance industry for the past 9 years roughly, and been working in other sectors for the past 10 years. Interested in a few things about cybersecurity, security architecture and whatnot. If you want to talk to me about anything outside, it can be any of these topics, neuroscience, piano, baking, landscape photography, whatever you feel comfortable with. Just a brief disclosure, opinions are my own and not representative of the firm I work for. Now, the agenda today, we're going to cover a few concepts. We're going to cover external software supply chain and threats, internal software supply chain and threats, software supply chain attacks and breakdown, risk-based deployment model, areas of opportunity, and what next. Ultimately, the slides are going to be available in the website. And given that the time is a little bit kind of like constricted, I'll take any questions outside if we don't have time at the session. Okay. So just to level set, what is supply chain? I mean, you should probably heard about this already too much, but in any case, so it's all the processes or all the people and all the material that's required to go through in order for someone to receive a product or a service. The same is true for software supply chain, right? And when we speak about supply chain security or software supply chain security, is how do we secure all of this together, okay? So the external software supply chain is composed of several external point of attacks, if you will. Now, there are personal software development environments like laptops, right? You have public source control management platforms like GitHub, GitLab, and whatnot, right? You have public build infrastructure services like Circle CI. You have public software registry like PyPy, NPM, and others, right? Then you have third-party software providers that can be any company. And then the cloud service provider marketplaces where you can actually consume other type of software, right? Now, the key part to understand about the external software supply chain is that technically the best that we can do is to influence, but we're not responsible of what happened in it, okay? And there are a bunch of threats that can manifest in this external supply chain. Now, this is a list. It might not be readable, but don't worry about it. There are like 4 family groups, development, name, squatting, and whatnot. So you probably have heard about them, right? And they will be available on the slides. So when we speak about the internal software supply chain, we typically speak about a development environment that then pushes code into a source repository, kicks off a build pipeline, might or might not put into a package registry the software, pick it up from there, and then deploy it through the deployment pipeline into an execution environment. Just to be clear, I'm calling it execution environment on purpose because it doesn't really matter if it's production, UAT, development, it's the same thing at the end of the day, right? So in an internal software supply chain, you will have as well a manifestation of different threats. And what you're seeing here is basically that there are several processes that exist outside of the typical SDLC pipeline. Now, in an open source perspective, you might not kind of like see them as broken down as if you were in a company, but you do have ingestion. You might not do procurement as consciously as it's called out here, but you still choose to actually bring in something into your laptop when you're developing software. You're also doing inventorying. It happens automatically when you do a brew install, right? And you basically start developing straight off the bat, okay? Now, again, the whole idea of this is for you to have a different perspective about risk in a software supply chain in general. But what really happens is that you're picking something that's external, bringing it internally, from whatever version into a fixed version into your system, right? And that goes through the processes that I just called out, which are ingestion, procurement, inventorying, consumption, and development. Now, the interesting part is that from a kind of like matter attacking perspective, the tactics that happen outside are reconnaissance, resource development, and initial access. But the key part with the supply chain attack is that it's the first step into an attack chain. And everything else can manifest when you're working with the software. And it can be as varied as it wants to be, right? It might be actually just trying to break down your system with malware. It might actually try to embed into your software to carry on with the next step in a software supply chain attack. So that's a key part to understand. Or put it differently, a software supply chain attack is an attack with potential, and I'm bracketing business because it might have other kind of impact, right? That exists within an attack chain that originates from the software supply chain. Now, typically, these attacks cannot be stopped at ingestion nor defended directly. Does that mean that we are kind of like completely useless against these kind of attacks? No, the answer is no. So we can achieve control. We try to understand what are the next steps in the attack chain, right? We implement a risk-based deployment model, and I'll talk about it in a bit, and we implement controls that reduce the residual risk. Now, for the risk-based deployment model, we have 4 factors. Now, you're seeing 4 factors here is because we're accounting for volatility. What that means is that whatever comes next in the industry, right now we are hyped with AI, right? That fits in data risk as well as it fits in software risk and external risk. Now, if I were to jump into data risk, you have been hearing that the data sets can be poisoned and they can be biased and whatnot, right? From an external risk perspective, you want to understand what's happening with the code that you're consuming, where it's coming from, the practices. We have the OpenSSF card, but there are quite a few more kind of like guidelines when it comes to open source altogether. Now, not everyone follows them. Does that mean that you actually take in the software because you want that capability? You might as well, right? But you are aware that there's a risk with that software. Now, from a software risk perspective, you will typically hear about known vulnerabilities in the form of CVEs, but it might be more than that. The reality is that it might be high-risk behavior for you, right? Depending on your threat model. How is that high-risk behavior kind of like an example? So think about it, right? If you have a system where you don't want connectivity externally, and the software that you're consuming actually tries to connect externally, what do you do about it, right? Now, in finance industry, it's a little bit different because you have something called externally mandated software, where you actually have software that you don't have the option to say no because regulations impose it on you, but you still need to handle it, hence this risk-based deployment model. Now, the licenses risk, it's a little bit kind of like obvious, but maybe sometimes it's not that much. So it's not only the type of license that you are working with, it's also how the license ties you in terms of the usage of your software whenever you deploy it, okay? Now, from a kind of like deployment model perspective, this is what you would call the target state, where you have basically everything that happens in the external supply chain, and you do an external risk assessment and continuous monitoring, right? You have producers, they have their processes that might be actually black boxed, right? And they deploy the packages into proxy sources, whether it's code dependencies or other kind of packages. Then that comes in, right? And you have ingestion, procurement, inventorying, as I called out, right? And we'll see the details into each one of these phases. But what you want is to achieve login, metrics, and traceability across the whole software supply chain. And you have areas of opportunity from a prevention, detection, and remediation perspective. Now, what happens when you ingest software? So typically, you would just run your terminal and call out brew install, and bam, you have your dependency and you're using it, right? But how do you know that it actually doesn't have something that's going to trigger when you actually run it? Shouldn't you be just trying to decrease the attack surface altogether? So the suggestion here is to actually sandbox the environment so that you can test it before you actually integrate it into your code. Now, there are a bunch of open source environments that can catch up on malware. So kind of like that's the guidance here. Now, why we need it, again, is to limit the attack surface, right? And to enable testing with freedom. For a procurement perspective, what you want to do is you want to think about, okay, I want to get this in, right? I want to do a risk assessment. And there are references towards the ends of the slides where you can use this, right? Then you want to evaluate your own risk threshold. Like, are you comfortable with this kind of software altogether? Based on the risk model that I just described with the 4 areas. And then you decide to take that promotion decision and you procure the artifact, right? Now, this is kind of like speaking to Salsa and other frameworks that you might have heard of, S2C2, I believe that's the acronym, right? Where you basically try to have transparency through the evidence and produce metadata for each of the steps that actually have been executed, okay? And again, this is just to account for the risk of consuming that software altogether. Inventorying. So you got something that is going to be listed for you to consume. Did it go through exactly everything that you were expecting it to go? Now, there are different kind of like package managers that are adapting to this to do those checks for you, but you need to verify them at the end of the day. Like, just simply because they say that they're working might not necessarily be something that you are comfortable with, depending on what kind of project you're working for. And even in the environment that you're working for, you might have something that's confidential information in your laptop. Are you comfortable just literally running whatever you want altogether? Okay? So again, these are checks on the processes that happen in the earlier stage altogether. And these checks also kind of like produce that metadata so that you actually have this chain of evidence that gives you kind of like the provenance of how this package has gotten all the way to the execution environment. Now, from a building perspective, same thing, right? You build something, you produce basically your building evidence. We have seen that already. You might have an S1 being produced. You want to check that the environment variables of the environment that build your package are captured. You want to check what are the dependencies installed in that environment so that it's not actually being kind of like corrupted, right? And then you do, again, the same thing, risk assessment, risk stressful evaluation, and risk-based promotion, right? And you put it into the package registry. And again, all of these kind of like speaks as well to what we already have out there, which is Sigstore, right? That's where that evidence kind of lives. But do you actually verify it? Can you actually create a script that actually does that for you, right? So again, this is all the way to deployment. Now, you may be wondering a little bit kind of like, okay, what's the whole point of this, of doing this? So we set the topic about risk because you want to deploy or create things that you are comfortable with, even if there's some risk embedded into it. And the ultimate goal is that you are able to stand up execution environments with risk-based controls on demand. Like that's the end goal, right? If you know that that software is going to connect externally because it needs to, right? Can you monitor the connectivity? Can you actually kind of like literally check when it connects, to where it connects? Are you comfortable with it? Are you comfortable that it's running something on memory, right? Like the kind of attacks that we have been seeing in the software supply chain out there that for good luck didn't manifest further, right? Like the XY set attack, right? So there were some checks in place, right? That kind of like spoke to the performance of a software that basically show the risk altogether. Now, again, I think that we are in 13 minutes. Okay, so just to recap, right? This is what you need to kind of like keep in mind at all times. The software supply chain attack will have a potential of any kind of impact, and it will exist in an attack chain that originates from the software supply chain itself. And this means that it's just the initial step in the attack chain, and that whatever comes afterwards, you might need to account for it. You might, again, I don't know what kind of projects you're involved with, but this is something that you might want to actually deal with, rather than just simply saying, oh, well, I don't want to consume that software. You cannot actually deal with it, right? But you need to understand what you're dealing with in order to manage it. So hopefully I didn't go too fast, but just to be clear before I go into the question section, this is the reference section. There are a bunch of annexes suggesting for some controls in the different kind of like components in your supply chain. The source repository, the building environment, package registry, and deployment environment. Again, they speak to what you already have seen externally, S2, C2, and SALSA levels, right? So yeah, any questions that I can take right now in the lapse of 5 minutes? Also, just before I forget, please provide your valuable feedback when you receive the form next week. I would really, really appreciate it. And that's it. Thank you. Any questions that I can take right now? I can go back to here. Maybe this, yes?
The top layer, the logging metrics and traceability.
Yes.
Can you speak to that? Is that one layer across everything, or does each step needs its own? What is your experience with that?
So ultimately, you are going to have several sources, right? We normally, in a corporate environment, we call this cyber intelligence. And we would kind of like have that traceability and metrics kind of like in different source of truth, right? And we would account for them. Like the whole idea is that they are actually visible and that you can actually integrate them, right? So yes, I guess the way to put it from the logging perspective, you would want to have evidence of what you did, for example, externally on your risk assessment, right? How is that continuous monitoring being informing the risk profile? Because at the end of the day, the reality is that things change, right? With software, things change. We discover vulnerabilities. We are informed of software supply chain attacks. So again, the whole idea of traceability is that you understand where it came from, where do you have it now, and what processes did it go through, right? So that's pretty much it. The metrics part is really up to you. Like, how many packages are you consuming from a specific provider? Does that mean that you're actually relying too much on that provider? And what does that mean for you? Do you actually need to care on monitoring, I don't know, an X account, LinkedIn account, or whatever account? Do you need to actually do more due diligence about the maintainers in that project, right? So it's a little bit kind of like integrating the data that speaks to what you're doing and what you're consuming all together. Does that address the question?
Yes, thank you.
Good. Anybody else? No? All right. Well, again, thank you very much for your time. I'm happy to take questions outside as well.